Welcome to my channel. In this video, we are going to learn what is electric power. When an electric current flows through a conductor, electrical energy is used and current is doing the work. The rate of doing the work, that is work done per unit time, or energy is used. So, rate of consumption of energy is what is called electric power. Now, let us define what is electric power. The rate at which this electrical work is done and the rate at which electric energy is consumed is called electric power. So, now let us write the formula for that. So, P is equal to work done per unit time. So, I will write this as W by T. Now, we know work is measured in joules and time in seconds. So, the power of this unit of power, electric power, SI unit of electric power is measured in watts, W-A-T-T. So, the power of 1 watt, is the rate of working of 1 joule per second. When you look at this, 1 joule per second. So, this is equal to 1 watt power. Then 1 kilowatt is 1000 watts. 1000 watts. So, how do we define now watt? How do we define watt? When an electrical appliance consumes electric energy at the rate of 1 joule per second, its power is said to be 1 watt. 1 watt. Now, let us derive the same formula. P is equal to W by T. Now, we know that work done W by a current I when it flows for the time T under a potential difference applied, V is given by W is equal to V into I into T. Therefore, power P is equal to V I T by T, substituting for W from this. So, this is one form of the expression for power. Now, this is equal to VI. So, I will now write another form from this. P is equal to VI. T gets cancelled. Therefore, P is equal to VI. Watts, of course, watts. So, if 1 volt is applied, 1 ampere current passes through, then there will be 1 watt power. Therefore, power depends on potential difference V or the voltage. Potential difference V between the terminals of the device, whatever electrical device. So, between the terminals of the device and electric current I flowing through it. Now, according to this, again we will define watt. Definition of watt. 1 watt is the electric power. 1 watt is the electric power consumed by an electric device which when operated at a potential difference of how much? 1 volt carries a current of 1 ampere. Now, we have defined watt according to this equation in terms of joules and seconds, and now we have defined again watt in terms of this equation in terms of volt and current. So, this is the definition of watt. So, watt is the SI unit of power. Now, same power we will now derive in terms of other expressions. Now, let us take this equation P is equal to VI. Now, using Ohm's law, we know V is equal to IR. So, I will now write I is equal to V by R or V is equal to IR. So, I will now take these two in this equation. We have seen this equation. So, in this equation I will now substitute for V. So, P is equal to IR into I. So, that is I square R. Therefore, the other form of the expression for P is equal to I square R. Or, now I will again substitute for I. So, P is equal to V into, for I if I substitute, this is V by R. I am substituting this. So, V by R. So, that is equal to V square by R. Therefore, I have the expression power is equal to V square by R. V square by R. So, now let us look at these equations. So, here it is equation number 1, let us say expression number 1, all are one and the same for the same power, and here it is expression number 2, and then this is expression number 3, and this is expression number 4. Now, from this one we can see that power is inversely related to resistance. That means, resistance of a high power device is smaller than a low power device. Example, resistance of 100 watt bulb if you consider and 60 watt bulb. here power is more. So 100 watt bulb resistance is less and 60 watt bulb resistance is more. Resistance is more. Now all these 4 different expressions for the same power, electric power, are used to solve numericals in this topic, which I will be doing it in separate video. Now from the first equation, energy consumed, so we can always write energy consumed per second in terms of power energy consumed per time, from which I get, this is one expression, from which energy consumed is equal to power into time. Power into time. Let's say this, I'll put it as another expression 5 of the form. Energy consumed by an appliance E depends on, so this E depends on number 1, power rating of the appliance, of the device, electrical device or appliance, and it depends on the time. So it depends on power rating and it depends on time for which the appliance is used. The power rating is actually measured, energy consumed by an appliance, that power rating is measured in terms of watt hour. So this is measured in terms of watt hour. What do we mean by that? Power of 1 watt in 1 hour, and hence the unit is watt hour. But commercially the unit is, commercial unit is kilowatt hour. Kilowatt hour. Commercial unit is kilowatt hour. Now let us quickly derive the relation between kilowatt hour, this power rating, and the work joule. 1 kilowatt hour is equal to 1000 watts for 1 hour. Correct? 1000 watts for 1 hour. Now 1000 watts is 1000 joules per second according to the definition of power. So 1 watt is joule second. So 1000 watt is joule second for 1 hour, and that is 1000 joules per second into, when I convert this 1 hour into seconds, 60 into 60. 1 hour is 60 minutes and 1 minute is 60 seconds. Therefore, converting that, 1 hour is 60 into 60 seconds. So that's how I got here for 1 hour as 60 into 60. So 1 kilowatt hour is equal to 6 into 6, 36. So 36. So I'll write this as 3.6 into 10 power 6 joules. So 1 kilowatt hour is the relation is this. Now with this I have completed all the topics in electricity, and few numericals I'll take in the next video. Until then, keep watching, keep learning. Thank you.